let's examine the different types of ports that we can have with rapid spanning tree protocol. Just like spanning tree protocol, we have our root ports and our designated ports. These are the ports in the forwarding state. So they're going to be responsible for receiving frames and sending frames. They're going to learn MAC addresses. They're part of the active spanning tree topology, making sure that traffic flows through that network. So the root port is the port on the non-root bridges with the shortest path back to the root bridge, as we can see here. And our designated ports are going to be the ports on the segments that are closest to the root bridge. And we can see that here, the designated port here. Well, they're directly connected to the root bridge, so you can't get any closer than that. This is the designated port that was chosen on this segment, being closest to the root bridge. And in this case, we have a shared segment. Right? This is a hub. If you weren't familiar with what this was right here, that's a good old-fashioned hub. And when we have a hub, this segment, this is all shared. So we're running in half duplex. And as a result, within that shared environment, we have that one designated port, which happens to be Fast Ethernet 0/1 in this case. So those are the ports in the forwarding state. The other two types of ports we will find are in the discarding state. So they are essentially blocking. That's what they are doing. They are not going to allow the frames inbound on the interface or outbound on the interface, and they are preventing a loop from occurring within the spanning tree topology. When you look at the alternate port, it's a port on a non-root bridge with an alternate path to the root bridge. So if we examine the alternate port in this case, which is right here, it is the port on this non-root bridge right here with an already predetermined alternate path to get back to the root bridge. What does this mean? It means if we have a direct failure right here, so this link goes down, a direct failure of the current root port, then this port does not have to wait for the BPDU to expire. It doesn't have to wait 20 seconds. Why? Because it's already been determined that this is an alternate port. It's the next best path to get to the root bridge and still maintain a loop-free infrastructure. So it helps speed up the transition. Don't have to wait for that BPDU to expire anymore. The other port is the backup port. It's the port on a non-root bridge that receives BPDUs from the same non-root bridge. Now, how can that happen? That will happen when you have a shared Ethernet environment, like we see down here. So our focus is in this area right here. That's our focus right now. As a BPDU is sent out this interface towards the hub, it will, because we have a hub here, be sent back up. Likewise, when a BPDU is sent out this port through the hub, it arrives back up. So this switch receives its own BPDU. The one that's sent on Fast Ethernet 02 comes in Fast Ethernet 01. The one that's sent Fast Ethernet 01 comes in Fast Ethernet 02 because hubs do not understand BPDUs. In actuality, hubs don't understand anything. What do hubs do? Traffic comes in, traffic gets spit out all ports except the port it came in on. That's how they behave no matter what. So in this case now, the switch has to determine based on receiving its own BPDUs as they go through that hub, which of the ports on this shared Ethernet segment is going to be the designated port. once it determines which port is the designated port, fast Ethernet 0/1 in this case, the other ports on that shared segment, like fast Ethernet 02 in this case, is a backup port. It's a backup port. So it is a port that can become a designated port if the BPDUs are no longer received from the other designated port on that shared segment. So if the designated port goes away, fast Ethernet 0/1 fails and fast Ethernet 0/2 takes over as the designated port. So it's a backup to the designated port on that shared Ethernet segment. Let me show you these two port roles in a live topology. On ASW1, let's type in show span for VLAN 10. Let's see if we have any blocked ports for VLAN 10, and we do. There's an alternative port, or an alternate port, for rapid spanning tree protocol. So we are using rapid spanning tree protocol. This is an alternate port, and it says here blocking. But as we saw, it's discarding. So it is really a blocking port. So the iOS is blocking. Terminology and documentation says it's discarding. Make sure you are aware of that terminology difference, which in reality means the same. But be aware of that. Can I demonstrate a backup port for you? Well, I do not have a hub. I don't. But one way you can simulate this is to plug a switch into itself. So that way there, when BPDUs are sent out of the switch port, the other switch port on the same switch receives it. So it's receiving BPDUs from itself. And that's what I've done here for VLAN 1. So show spanning tree for VLAN 1, I managed to plug in fast Ethernet 09 and 10 into each other. And so since I plugged this one Ethernet cable into 09 and the other into the 010, there's the designated port that was determined, and there's the backup port. So if all of a sudden fast Ethernet 0/9 goes away, then this port automatically becomes the designated port for this shared Ethernet segment. And it's classified as a shared Ethernet segment from spanning tree's perspective because of the fact that a BPU that was sent out on one port comes in another port on the exact same switch. So it's important that you're fully aware of these different spanning tree port roles. Root, designated, alternate, backup, and know that root and designated are forwarding and alternate and backup are discarding.